Welcome to The Explainer. Today we are diving into one of the absolute cornerstones of programming, Python functions. If you can get these right, you are well on your way to writing code that's not just clean and efficient, but genuinely powerful. So let me ask you a question. What could making a cup of tea and writing code possibly have in common? It sounds a little weird, I know, but they are way more similar than you'd think. See, both of them involve following a specific series of steps to get a result. And let's be real, whether you're in the kitchen or in your code editor, repeating those same steps over and over again is just plain tedious.
Just think about making a cup of tea for a second. It's a recipe, right? It's a defined set of instructions that you follow every time to get a predictable, hopefully delicious, outcome. Well, in the world of programming, we have the exact same concept. We just don't call it a recipe. We call it a function.
Okay, so let's get into the why. Why do we even need functions? At their heart, functions are basically named recipes for your code, and they exist for one huge reason: to save you from repeating yourself.
Imagine this. You've got a block of, say, 10 lines of code that you need to use in 50 different places throughout your program. Now, you could copy and paste it 50 times, but a much, much better way is to write it just once. Wrap it up inside a function, give it a simple name, and then just call that name whenever you need it. And here's where they really become a superpower: maintenance. Sooner or later, you're going to need to update that logic. Instead of hunting down all 50 of those copies, you just change the recipe in that one single function, and boom, the change is instantly reflected everywhere else. It's efficient, it's clean, and honestly, it's a total lifesaver.
All right, let's break this down. Every single function, I don't care if it's a simple one-liner or a massive, complex algorithm, is built from three core parts. If you can get these three things, you've mastered the fundamentals.
So first up, you've got the declaration. This is where you give your function its name and you define its ingredients, or what we call parameters. Next is the body. This is the meat of it, the actual step-by-step instructions. And finally, you have the call. This is the part where you actually tell the program, hey, run that function now. And this is a really crucial point. Just defining a function doesn't do anything. It's like writing a recipe in a cookbook. That recipe just sits there on the page, right? It doesn't magically cook itself. You have to explicitly call it. You have to decide to use it for the magic to happen and for that code to actually run. Now, it's also really important to get that not all functions act the same way. Some of them are built to give you a value back. Think about the len function. It does a calculation and it hands you back a number that you can store in a variable and use later. But then you have others, like print, that just perform an action. They do something, like display text on the screen, but they don't actually give you anything back to work with. Okay, so we've got the basics down. Now let's talk about where functions get really, really interesting. Python gives us some specialized tools that are kind of like superpowers for your code, each designed for a very specific kind of job. First up, let me introduce you to the Lambda function. Think of this as a quick and dirty disposable function. You don't even have to give it a formal name. It is absolutely perfect for those little moments where you need a simple operation done right now, just once, and you're probably never going to need it again. And you can really see the difference right here. On the left, you've got a standard function to double a number. It takes at least 2 lines. But on the right, a Lambda function packs that exact same logic into one single, elegant line. It's clean, it's concise, and it is so useful for these little one-off tasks. But here's a classic problem. What if you need a function to be super flexible? Like a sum function that could add 2 numbers, or 20, or maybe even 100? Well, Python handles this beautifully with something called args and kwargs. This is just special syntax that lets your function accept an unlimited number of inputs, and it neatly packs them into a tuple or a dictionary for you. All right, now for the real power-up. We've talked about handling 20 numbers. But what happens when you're not dealing with 20, but with billions? How in the world do you process these massive data sets without your computer just completely crashing? So just try to picture this. You have a file, maybe a log file or some data set, with 1 billion items in it. A billion of anything. So, how do you process all of that without your computer just giving up? Because if you try to load all 1 billion of those things into your computer's memory at the same time, you are going to have a very bad day. For most machines, it's just impossible. The program will slow to a crawl, it'll freeze, and eventually it's going to crash. So, what's the workaround? The old way, the brute force way, would be to just try and load everything. The much smarter way, the generator way, is to process that data one single piece at a time. See, a generator function doesn't create the whole giant list in memory. Instead, it generates each value on the fly, and only when you ask for it.
I love this analogy. Think of a generator like a doctor's office. You wouldn't bring every single patient into the exam room at once, right? That would be total chaos. The doctor sees them one by one, and when they're done, they call next. Generators do the exact same thing with your data, which keeps your memory usage incredibly low. The magic word here is yield. Instead of return, which ends a function for good, yield hands you back one single value. And then it just pauses. The function literally freezes in place, remembering exactly where it left off, and it just waits patiently until you ask for the next item. It's brilliant.
So when you put all this together, we've basically built up an incredibly powerful toolkit for writing code. Let's just do a quick recap of all the different tools that we now have to work with.
You've got this whole versatile set now. You have your standard def functions for all the main reusable recipes in your code. You've got lambdas for those quick one-and-done tasks. You have flexible functions with args and quargs for when you don't know how many inputs you're going to get. And you have the memory-saving superpower of generators for tackling huge amounts of data. You know, the mark of a truly great programmer isn't just knowing that these tools exist, it's knowing when to use each one. It's all about choosing the right tool for the job. And now that you really understand the different types of functions and what they're good at, you are totally equipped to write cleaner, more powerful, and way more efficient Python code. So the only question left is, you've got the recipes, what are you going to create?